Hi, good afternoon, everyone. So I'm Bhanu from IBM Research New York, and I'll be basically talking about our Science for Social Good program. And in this talk, I plan to cover 3 projects in particular, and I will be talking about some of the machine learning components involved. So this might be a bit heavy on the ML, but I have trimmed it down so that you can all have some takeaways from this talk. That's the whole point of being here, right? So I think this is what everybody has been talking about today, that AI is influencing us in many ways, maybe beyond what we want. So the question is, what all can AI accomplish? And I think almost 70% of the talks we had today have stressed about the Sustainable Development Goals. And why I have put this up here is because in our Science for Social Good program, what we have done is we have made a conscious effort to map whatever projects we are taking to one or more SDGs. So let me briefly explain you how this program works. So I'll be sharing some numbers later, but we started out as a unit in 2016, a group of scientists, and we hired people as Science for Social Good postdocs and interns to come and work on these projects dedicatedly. And you will see that the end goal was not just a paper, but we are trying to come up with takeaways which can actually help and make an impact. So the whole point of this exercise is you want to make an impact. So this is our website, and I think the link is there on the agenda also if you want to have a look at it after the talk. And now let me get to the good stuff. So this is the first project I would like to cover. You can see that what this project is basically talking about is how do we define innovation. So you can see that this has been mapped to SDG 9. So what is happening here is that World Economic Forum has what is called a Global Competitiveness Index report, where they publish countries and they are ranked on pillars. And the 12th pillar is innovation, which is a score from 1 to 7. So when you have such data coming from the World Economic Forum about Global Competitiveness Index scores, you also have data coming from the World Bank on what are called World Development Indicators. World Development Indicators measure a country from several aspects. So now at this point, what you're trying to do is, can I define what is innovation? Because innovation can have different meanings for different countries. For some countries, it might mean the number of patents you're publishing. For some countries, it might just be improvement in your literacy. So how do you model this? So at this moment, this is not a prediction problem. This is a causal inference problem. So you'll be seeing this theme throughout my talk, that I'll be talking about causal inference a lot. So I'm assuming the audience here knows what causality is. So there is this famous quote which says that correlation does not imply causality. So I'm making that naive assumption, and I'm going ahead. So the way we modeled this problem is, when you have the World Development Indicators and you have a response which is the innovation score, you want to identify a set of indicators which clearly are causally related to the innovation score of a country. And to do this in a causal inference setting, you want to do this in a past influence the future. So whenever you're trying to predict something in a causality setting, you have to take time into context. I cannot predict the future, but I can always look at my past to know what causally caused why I am today in this particular situation. So to make that more clear, if you look at this particular result here, which we got, I'll explain the setup for this. So what we did was we took data of several economies, and I have just indicated 3 countries here: Bangladesh, Pakistan, and Singapore. So here the comparison is Bangladesh is an economy which is trying to improve. Pakistan is also similar, but Singapore is an economy or a country which is doing really well. So what we did is we implemented our Granger causal inference framework, which can come up with those set of indicators which define innovation for that country. So you can see that for all the World Development Indicators, our model assigns scores indicating how much did it contribute to innovation in that particular year to that country. And we come up with an overall estimation. Now, when you try to look at this card here, the question is, how do you know you are correct? So that's where causality becomes very interesting, because in causality, ground truth is not available, or it is difficult to obtain ground truth. You need a subject matter expert, or you need someone who can educate you on what is right and wrong. So what we did is we took certain survey results we had on what were the levers. I use the word lever here because a lever is what can actually influence the outcome. It's called a causal lever. We look at levers which were ranked according to how they impacted innovation for a country like Bangladesh. And you can see that the ones marked in red are those which have been identified by our model also. So in one way, what we are doing is we are doing validation of our approach. And a very key interesting fact here is the left result is completely data-driven, whereas the right result is based on surveys. So we are actually learning data-driven knowledge using a causal inference approach and trying to understand what are those factors which lead to innovation of a country and validating it with what subject matter experts know. This is how we are capturing the whole essence of innovation. And you can see that there are several interesting insights which I cannot share now, but you can look at a couple of papers which we have on this topic. And we have looked at this problem from several angles, because this is a technically very challenging problem, because you're doing causal inference in a time series setting. And that is something which we are exploring at depth. I'll now move to another problem which we have looked at. So when I say the US opioid problem, the reason I call it the US opioid problem is because it's more prevalent in the United States. But drug abuse as such is something which the whole world is suffering from. And these are some startling numbers which might appeal. And I think many of you all know this also, that it is a growing number where the number of deaths with opioid abuse is becoming more and more. So the question is, what can be done? How can you actually address addiction? So to come to the core question here is, what is addiction? Can you define addiction? There are multiple terms out there. Addiction, abuse, overuse. What are you even trying to accomplish? So this is something where we had to do a lot of brainstorming with clinical experts from our partner, that is Watson Health. And we had to talk to them to figure out what are the kinds of characteristics you are looking for. Because the whole point of this exercise was that we just don't want to churn a paper. We want to come up with insights which can actually educate prescribers on what they should be doing. So right now in the United States, what is happening is prescribers, whenever somebody comes with chronic pain, they will just overprescribe. Okay, just give you 1,000 milligrams of opioids without even considering why they are coming in. And there are several other nuances to this problem which makes it more complicated, like family members coming in and taking opioids for their friends, which is like illegal, but that does happen. So how do you actually even address such a problem? So what we do is we have access to real good data. That is one thing. As IBM, we have access to claims data which has, I must say, really good knowledge on different kinds of medical claims which were filed. And you can see that we are now at this particular time point trying to identify that given that a patient is an addict, that is, he's a short-term use or a long-term opioid use, we want to identify that what caused the abuse. We are not trying to predict abuse. This is not a prediction problem. This is a problem where we are trying to say what caused the abuse. And whatever we learn out of this process, like addiction patterns, prescription guidelines, all these will be translated into a white paper, which will eventually be used by prescribers. So that is the end goal. So we defined the entire scope of this project. And you can see that some of the preliminary results, which I'll be talking in the next slide, we did publish it recently at an American Medical Informatics conference. So some key takeaways for people who are wondering, like, what we have achieved is that we inferred that longer days of supply on the initial opioid prescription is a driving force. So in the limited time span of exploring this problem, we only looked at the initial prescription, although there are many ways of looking at, recurrent prescriptions and trying to model the problem. And more importantly, when we are trying to look at this problem, we observed that longer days of supply and usage of synthetic opioids in particular compared to natural or semi-synthetic was linked more strongly with addiction. And you can see that at this moment when we implemented this problem, this opened doors to several ways of looking at this problem now. That is, can you actually identify cohorts in the population and stratify the population in such a way that you can identify cohorts which have an enhanced treatment effect. That is, given a particular drug, you are having a cohort in the population which has an enhanced treatment effect compared to the other subgroups. The whole point of this is, once again, is we want to make sure that the prescriber is able to avoid overprescription, the first thing, before doing anything else. And as I said, this problem is not just limited to opioids. We want to extend this framework to general drug abuse. So far what I have covered is, I have covered two problems we looked at. The first one was defining innovation and how we looked at it as a causal inference problem. The second one was addressing the opioid crisis, which again I looked at it as a causal inference problem. But at the same time, now what I want to do is, because of the kind of people we have at IBM Research, we are able to leverage our scientific expertise in different strengths with people who come and start working on projects with us. So I'm going to talk now about some work we did on addressing bias in data. I know many people have talked about bias today, so this might appeal to that part of the audience who are interested in this particular topic. So when I talk about bias, it is very clear that this is something which is in news, and you know that this is a problem which needs a proper solution. So now the question is, what are we doing? Are we just improving over something else which others have done in this domain? The answer is no. What we have done is, we have come with the first approach, which given a data, can pre-process it to remove bias. Now to explain this simply, when I give you a data set and you are a data scientist or a machine learning person, what you try to do is you try to normalize the data, or you try to clean the data. What we have done is, we have done the same thing with respect to bias. You give me a data, I have an expert who informs me that this is an attribute which is a protected attribute. We have an algorithm or an approach which can debias the data. So we have a pre-processing for bias. That is what our fundamental approach here is. So I'll be explaining some technical nuances of this approach. If it goes over your head, no issues, but the whole essence of it is, this is what we are trying to do in this particular algorithm. So there are several ways of addressing bias. So you are looking at factors such as group discrimination. That is, you don't want outcomes to depend on which group you are a member of. That is, if I am implementing, say, a classifier which can approve your loan, a classifier which can approve your loan should not be looking at attributes such as race and gender. That is the first thing. So that is called group discrimination. Secondly, when I say individual distortion, let me explain this concept to you. So what our approach is trying to do is, if I have, say, an African American lady who is highly educated and whose income is more than $50,000 per annum, still her loan is rejected. This is how the data looks like, because there is bias in the data. Now what our approach will do is, it will increase the education level of this lady, and it will also increase the salary so that this lady her loan is approved. So it is a way of controlled increment of a particular instance so that the loan approval classifier has debiased the data. That is, in a nutshell, explaining how bias is handled by our approach. So we do a controlled randomization of the data so that such kind of instances are handled, and this is not done at an instance level. It's done at an algorithm level. And you can look at the paper for particular details of this pre-processing approach. And finally, when I say utility preservation, what we are trying to do is, we are trying to ensure that we are faithful to our original task. Our original task was a loan approval task. We want to be faithful to it. So this is a tool which is open sourced, and you should definitely have a look at it. This is called our AI Fairness 360 toolkit. please have a look at it and see how practically our algorithms work in the context of fairness. So now what I will do is, this is showing the entire, it's not even the entire scope, but I've just outlined some of the projects which we are looking at along with the partners. Like some really interesting work which we are doing is on creating new antibiotics. So antibiotic resistance is a problem which is something you just hear of, right? But by 2040, this will be an epidemic. You will have antibiotic resistance at peaks. So we are now developing methods which can create new antibiotics, and these are being tested in a wet lab in a real-time environment. That is one of the projects we are doing. In addition, we are doing projects with St. John's Bread and Life in New York City, which is trying to empower poor people. The whole effort of the project is that when poor people come in, we want to improve their quality of life. But this can be modeled as a machine learning problem by making sure that poor people who come in don't quit the program. They actually complete the program. So we are, some of these are actually completed projects, and you can see that others are the ones I spoke of at a high level. These are some numbers about the Science for Social Good project, how we have been running it, the number of fellowships awarded, and you can see that a lot of effort has gone in this project. And as I said it again, this was a dedicated effort and not an effort where you just spend 10% or 20% of your time trying to do social good. And finally, I have to thank the two people who have been responsible for this project mainly, Sashka and Kush. Sashka couldn't be here because of prior commitments. And yeah, that's it from my side.